Hi guys, Miss Keene here, and today I have a helper. Her name is Morgan, but you'll hear from her a little bit later. Today's video lesson is on real numbers, rational numbers and irrational numbers. And as you can see, I have a Venn diagram set up here. Please follow along and fill in your green note sheet. There's a spot for a Venn diagram, so you should be writing down the Venn diagram that's going to appear on your screen onto your paper. If any time you need to pause or stop the video or replay the video, please feel free to do so. All right, in our Venn diagram, we have our first category, which is rational numbers. Now, a rational number can be one of two things. It can be a repeating decimal, or it can be what's called a terminating decimal. And on our screen, we have some examples of each of those. A repeating decimal, you guys are used to that because many times you want to change fractions, such as 1/3, to a decimal, and you know that the repeating decimal is 0.333 with the repeating sign over it. Another example is 0.181818 with the repeating sign over 18. Anytime you have a decimal with the repeating pattern, a repeating decimal, that is a rational number. Rational numbers also include what is called terminating decimals. Now the word terminating, when you think of that, you should think of something that ends. Terminating meaning to end. So after the decimal, there's an end to it. And we have some examples on the screen for that as well.
Such as 0.5 and 0.25.
Excellent job, helper. So you can see the examples there. And on the other side of the Venn diagram are your irrational numbers. We have talked about irrational numbers in class recently when we've talked about square roots. In the definition of an irrational number is a decimal that does not have a repeating pattern or an end to it. And most recently, when we were talking about square roots, we decided that if it was a prime number and you were taking the square root of a prime number, that was an irrational number. I do have some examples here on the screen. Could you help me out and tell me what they are?
0 square root of 2, square root of 5, square root of 11.
Okay, good. And then we also have a symbol down below which we use quite often in class. And what is that?
Pi.
Right. In pi, we often think of it as 3.14, but we know that there is no end to pi. It continues on into infinity. Now, how this is all tied together is that you can see in the center the word real numbers. Rational numbers are real numbers, and irrational numbers are also real numbers. So that's why they overlap in the middle. They're both considered real numbers, and they both have their own definitions. Okay, at the bottom of your page, I'm going to ask you for some examples of rational numbers and irrational numbers. And before we do that, here's my helper again, and she's going to give you a couple of her own examples. Here we go. So rational numbers. Give me some examples of rational numbers.
0.7 and 0.92.
Okay.
92.
And give me some examples of irrational numbers.
Square root of 13, square root of 41.
Good, excellent. So when you're deciding your own examples at the bottom, please do not use any of the examples that I've talked about in this video. Come up with your own. All right, thank you. See you later.